Today we're going to look at graphing inequalities, and our objective is to first graph the inequalities, but also to determine if a point is a part of a solution set. So when we think about graphing linear inequalities, there are really kind of three steps that we want to think about. The first step is going to be to graph your actual line. So this piece is not really necessarily new for you. You're going to graph from slope-intercept form. So if you need to rearrange your equation, you would want to write it in slope-intercept form. And then when graphing an inequality, there are two kind of extra things that we need to think about. The first thing you think about is if you use a dotted or a solid line. So if you have a less than or equal to or a greater than or equal to sign, we're going to use a solid line, because the equal to piece means that that line is included. So similar idea to a closed circle when we were graphing on number lines. If you have just the less than symbol or the greater than symbol, we use a dotted line, and that's the same idea as an open circle, if you remember doing that. We use a dotted line to show that the actual line is not a part of our solution set, but then we'll talk about a shaded region. So no matter what type of symbol you have, whether it has an equal to or not, we do have to think about shading with inequalities. And the reason that is because there are a lot of possible solutions to an inequality that lie within a particular region. So you can do this two ways. You can test a point and see which side is true. I'm going to give you a shortcut. If you have the less than or equal to, or just the less than symbol. So if it's any version of less than, you're going to shade down from your line. If you have the greater than or equal to, or just the greater than, you'll shade up. And this only works when your line is in slope-intercept form with the y on the left, but for our purposes with graphing, it typically will be, so this shortcut will work for us. So let's jump right in with a couple examples. For number one, I see y is greater than 1/3 x minus 5. So this one is essentially in slope-intercept form with the y on the left and then everything else on the right. So just like when we were graphing linear equations, the first thing we're going to identify is our y-intercept. So my y-intercept here is -5. So I'm going to put my y-intercept down at -5. And my slope is 1/3. So I would go up 1 and over 3. I'm going to go a little bit in the other direction too. I'm going to go down 1 and left 3. Just to extend my line a little bit further. So I've got my points. Now before I do anything, I'm going to make some notes. Because we have the greater than symbol without the equal to piece, we're going to have a dotted line. And again, that's because our symbol does not have the equal to part. So we'll use a dotted line. And then for our shading, the greater than symbol would be to shade up from that line. So let's look at what this looks like visually. So we're going to connect those dots with a dotted line. And then from that line, we're going to shade up. Sometimes I think it's kind of tricky to tell which side is up and which side is down when your line is really steep. So something that can be helpful is to go to your y-intercept and draw an arrow either up or down depending on which way you're trying to shade. So we're going to shade up for this one. So this whole region gets shaded. So what that shows us is that shaded region has all of the possible points that would make this inequality true. So anything in our shaded region is a solution. Anything on a dotted line would not be included. So we are allowed to get really close up to that dotted line, but the actual dotted line itself are not solutions. They do not make this inequality true. All right, if you think you've got it, pause and try number 2 and turn it back on when you're ready to check. So our y-intercept would be at -1 here. Our slope says -2, so if I need to, I can put a 1 in the denominator. So down 2 and right 1. Again, I'm going to extend the other way just a little bit so I can see kind of where my line goes a little bit better. And now we've got to decide about dotted or solid as well as shading. So for this one, we're going to have a solid line because the symbol says less than or equal to. That little line under there is what tells me to use the solid line. And then the less than part is telling me to shade down. So this one will get a solid line, which means that anything on that line, since it's solid, can be a part of my solution set. And then we need to shade down from that line. So again, this one's a little steeper, so sometimes seeing which side is up versus down is tricky. So I like to go to my y-intercept, draw an arrow down, and that's the side that I'm going to shade. So we'll be shading all of this part. So again, anything in that shaded region and on the line would be a part of my solution set. Right. In numbers 3 and 4, we're going to have to do some rearranging to get y by itself. So again, this is actually not something new, but probably a good review for you. When we need to get y by itself, the first thing we do is move the x to the other side. So I would subtract 5x. I do the opposite since it's positive. And that would give me -2y is greater than, and then remember we actually can't do 12 minus 5x because they're not like terms, so we're going to put the x first, -5x plus 12. And the only reason we put that x first is so that it looks like slope-intercept form, y equals mx plus b. The x typically comes before the constant. My last step would be to divide everything by -2. To get y totally by itself. And now remember, when we solved inequalities, we said if we divide by a negative on both sides, we've got to flip that symbol. So we are going to need to flip that inequality symbol. We would say y is less than -5 divided by -2 is just +5/2 x, and 12 divided by -2 is -6. And now from here, just like the other problems we did. So I'm going to put my y-intercept at -6. My slope is 5/2, so I'm going to go up 5 and over 2. Do that a couple times. And then I've got to make my decisions about dotted or solid line. So for this one, we would pick a dotted line because our symbol is less than. So it does not have the line under it, so we're going to connect these with just a dotted line. And when I make my decision about shading up or down, remember I have to work from the slope-intercept version. So that's what I'm looking right here when I got y by itself. So that less than symbol would tell me to shade down. So from this line, I'm going to go to the y-intercept and see which side is down from there, and that's the side we're going to shade. So all along here. Would be our solution set. All right, again, if you're ready to try number 4, go ahead and try number 4, and if not, we'll go through it together. Feel free to pause if you are going to try that. So just like the last example, we need to move the x first. It's a positive x, so I'm going to subtract x on both sides, which gives me -4y is less than -x plus 8. Divide by -4. Everything gets divided by -4, which will give us y is greater than -x divided by -4. You can put a little 1 there if that helps you. -1 over -4. A negative divided by a negative will simplify to a positive, so I can call that 1/4 x. 8 divided by -4 is -2. So we start our graph, y-axis, at -2. We're going to go up 1 and over 4, according to our slope. can go the other way, down 1 and left 4. And once we get those points here, we've got our two things to think about, dotted or solid. So we should have a dotted line here because that symbol is just greater than. It does not have the equal to piece. So I'm going to connect with a dotted line. And then my symbol, when I got it in slope-intercept form, was greater than. So we need to shade up for greater than. So from the y-intercept, we're going to shade up on that side, which would be this whole section. We've got quite a few more examples on the next page for you. So at this point, I think you're probably ready to try 5 and 6. Go ahead and pause and give those a try. And then restart when you're ready, and I'm going to just go over those pretty quickly. In number 5, when we get y by itself, we would subtract the x on both sides. So that would give us negative y is greater than or equal to negative x plus 8. And then divide everything by a negative 1 to get rid of that negative y. So that would be y, I have to flip my inequality sign, is now less than or equal to negative x is the same as negative 1x. So negative 1 divided by negative 1 makes a positive 1x. 8 divided by negative 1 would be negative 8. So our y-intercept is negative 8, and our slope is 1, which means we'll go up 1 over 1. And now this line should be solid because it did have the equal to piece in our symbol. And when I decide which direction to shade, again, I've got to use the version that says y equals. So, or that has the y on the left side. It doesn't say y equals. It says has the y on the left side, which is right here. So less than or equal to. So that would be to shade down. So again, from my y-intercept, I'm going to shade down, which will be on this side. And now in this solution set, everything on the line and the shaded region is a part of our solution. In number 6, I need to subtract 3x on both sides. So that will give me 2y is less than negative 3x. I'm going to leave that 0 there. It might help us when we graph. So plus 0, and then divide everything by 2. So now here I'm dividing by 2. So I do not need to flip my inequality sign. I'm dividing by a positive number. So that would give us y is less than negative 3/2 x plus 0. So our y-intercept is 0. Slope is negative 3/2. So I'm going to go down 3 and to the right 2. I'm going to go a couple times the other direction. Up 3 and left 2. Now this one should be a dotted line because we do not have that equal to piece. And less than tells me to shade down. So I'm going to shade below my y-intercept, below all of that line, which would be this part right here. All right, number 7 and 8 are a little different, nothing wild, but those are going to be our horizontal and vertical lines. So remember when we have a y is equal to negative 4, we'll start with the line. That would be a horizontal line at negative 4. So it's going to cross right through the y-axis at negative 4. And that will be a sideways line. I know it should be a solid line because it has the equal to piece in my inequality symbol. So I've got this solid line at negative 4. And then it does say less than, so we need to shade down or below the line. So shading below that line, it's pretty clear when it's a sideways line. We're going to shade this part. So anything on that line or below it has a y that is less than or equal to negative 4. In number 8, that says x is greater than 7. So if we are at greater than 7, x lines are our vertical lines. So this one's going to go right through the x-axis at 7. It will be dotted because we've got just the greater than symbol. There is no equal to part there. So dotted line. And that says x is greater than 7. So this is the only time when you have an x and then your inequality symbol that your shade above or below won't work. But think about it logically. If we're talking about our x values, x would be greater as we move to the right. That's where our x values get greater than whatever we already have. So this side would be my shaded region here. All right. Last problems are, it's already graphed for us, so we're just going to analyze if each point is a solution to this inequality. So the way, I'll do the first couple with you. Point A says 3, -4. The way I would do this, I would suggest actually just graphing it. So 3, -4, let me pick a bright color. 3, -4 would be right here. So that's point A. And that is in my shaded region. So that one is a solution. Let's do another one. If I graph B, 4, 1, that would be right here. Now that's on a dotted line. Dotted lines are not included in our solution set, so that would be a no. We'll do one more together. -3, -4 would be over here. That's point C. That would be just barely in our non-shaded region, so that is not a solution. And now you try the rest, pause, decide if those are solutions or not, and then we'll check them together. So the point 0, 0 is not a solution, not in our shaded region. -4, -5, point E is going to be right on the dotted line, which is not included. Now again, if it was a solid line, we would be allowed to include it. 1, -10 would be somewhere way down here. It's off our graph, but I know that shaded region is going to continue. So that one is going to be one of our solutions. And -1.5, -5 would be right here, which again is in our shaded region. So yes, that is one of our solutions.